In this lecture, I will introduce Bada's buffer class. Although in general, the buffer class is similar to an array. The class performs the role of the buffer using the internal values of the position, limit, remaining, mark, and capacity because it has been designed as a buffer. We will look at each of these in detail. First, the position is the value that remembers the position where the data was written to or read from in the buffer array from the last operation. Therefore, if the read or write operation is performed in the buffer, the position value saves the position at which to read or write the next time. The limit value represents the last position in the buffer where meaningful data is written. The remaining value represents the amount of remaining data space. That is, the remaining value represents the difference between the position and the limit values. The mark value is the position in the buffer specified by the user for an operation. Users can move the position to the position indicated by the mark value. And the capacity value represents the maximum capacity of data the buffer can hold. To actually use a buffer, you do not need to use the buffer itself, but the buffers implemented for each and every specific type. Great. Let's take a look at the basic operations of the buffer. First, the setPosition function is used to set the position value to a specific position in the buffer. The rewind function is used to move the position value to the beginning of the buffer or to perform the read or write operation again. The flip function moves the limit to the current position and sets the position to 0. The flip function can be used when you have written data to the buffer and are about to read the data from the buffer. For example, if writing to the buffer is completed, the buffer's position value would indicate the end of the data within the buffer. At this time, if you call the flip function, the limit is set to the position indicating the end of the meaningful data, and the position is returned to the beginning of the data in the buffer in order to prepare for the reading operation. And as I mentioned before, the reset function is used to move the position to the location indicated by the marker. Besides these functions, functions to get the memory size, limit, mark, and position of the buffer, functions to get the length of the currently remaining meaningful data, and functions to identify whether there is remaining data are also provided. The following functions to read or write to the buffer are provided. The get and set functions get and set data at the current position and then move the position accordingly. To get or set data regardless of the current position, the absolute function and the square bracket operation are supported. Additionally, functions to save data in the C array type and directly get the C array pointer are also supported. Also, a read from function is available. The read from function is used to read data from the buffer and is generally used to copy data from a relatively large buffer to a smaller buffer. Besides these functions, the functions and operators to compare the data of buffers are provided. Okay, let's have a look at an example of using a buffer. First, we have to initialize the buffer. We've declared an integer buffer and defined the buffer size using the construct function of the buffer. Then, we've set the buffer with the C array data by calling the setArray function. The flip function is called to read the data from the beginning of the buffer because the setArray operation would have set the position to the end of the valid data. After this, we get the data in sequence by calling the get function of the buffer using a loop until there is no remaining data in the buffer. As mentioned earlier, since the get function moves the position one by one whenever it reads data, we can read the data in the buffer sequentially. Then, I've set the position of the buffer to 6 and set the length of buffer 2 to 2. Then if I read the data from the buffer to buffer 2, since the position of the buffer is set to 6, the 2 elements after the 6th element will be read. After this operation, 7 and 8 will be in buffer 2. If I rewind the buffer and read it again, 9 and 10 will be added to buffer 2. So as you can see, you can conveniently use the buffer to record and read data in an array sequentially. The interesting thing here is that the construct function of the buffer. The construct function performs a two-phase construction, which is a feature of bada. Now I will explain a two-phase construction in detail. There are times when there is a problem in the C++ constructor. For example, in general, the C++ constructor performs initialization and memory allocation tasks. Sometimes this can cause a problem. If, for example, the constructor fails in the middle of allocating memory, the destructor is not called, since this class has not yet been constructed. Then, any memory that was allocated before the failure in the constructor cannot be used. To resolve this problem, bada uses a two-phase construction mechanism. The basic idea is that the C++ constructor only constructs the class, and then the memory allocation is performed by another function. Now, I'll show you how to use this in bada. Most of bada's classes do not allocate memory in the C++ constructor. If memory allocation within the class is necessary, a separate constructor function is used. In this construct function, memory is allocated. In this case, even if the constructor fails to allocate memory, the destructor can still be called and the problem can be resolved. Let me explain in more detail by looking at the source code. First, in C++ generally, memory allocation is performed in the C++ constructor. However, in this case, as mentioned earlier, a memory leakage problem may occur. Therefore, in bada classes, in order to resolve the problem, memory allocation is not performed in the C++ constructor, but in the construct function of the class. As you can see in the actual source code of the form class, when a new form is created, the memory necessary for the form is not allocated. If the construct function of the form class is called, the memory necessary for the form is allocated. After that, the operations of the class are performed. The OSP base namespace provides the DateTime and TimeSpan classes. The DateTime class is used to represent the absolute time, and the TimeSpan class is used to represent the time difference between two time values. The value returned by the time span is in milliseconds. In the DateTime class, functions to add the time span, years, months, days, hours, minutes, and seconds are provided, and the functions and operators to compare the date time are also provided. Additionally, functions to set or get each of the properties are provided. A function to return how much time has passed since the minimum value of the date time as a time span value, and a function to return how much time has passed since midnight of a day as a time span value are also provided. Besides these functions, functions to convert the current date time into strings, to identify whether this year is a leap year or not, to find the day corresponding to a date, and to get the date time from a string are all provided. The TimeSpan class provides the following functions. First, functions to represent a time span in days, hours, minutes, and seconds are provided. Functions and operators to compare two time span values are also provided. And of course, you can add or subtract time span values. Additionally, duration, functions to get absolute values from a time span value, and the negate function to negate a time span value are provided. Finally, The OSP base namespace provides the UUID class that is used to represent a universally unique identifier. Functions are provided to identify whether two UUID values are the same, to convert a UUID into a string, to convert a string into a UUID, and to convert a string into a UUID value. Okay, let's summarize this lecture. First, the object class is the base class of all bada classes, and bada has adopted a two-phase construction via the C++ constructor and the construct function of the class to manage memory more safely. Additionally, the base namespace provides various type classes to wrap C types, the string class and the buffer class, which supports various types.